Hi, this is AJ from Hound, and in this video I'm going to show you how to use the PN400 to characterize a VCO. The PN400 is a new product from Hound used for high-performance phase noise measurements and VCO characterization. The PN400 has two low-noise DC sources that can be used to source voltage for the tuning and supply ports that are found on a typical VCO. Combined with the licensed Spike software, you can sweep those voltages across a configurable range to measure frequency, current, power, harmonics, and sensitivity. Combined with the full automation capabilities of Spike, this makes the PN400 a great choice for the manufacturing line and for lab work. All right, so let's take a look at this setup. In this video, I'm going to be sweeping a wideband VCO. This is a 10 to 20 gigahertz VCO, and we're going to be measuring it with the SM435B. So the SM435 is connected to our PC over USB, connected to external power, and the RF input is coming from our VCO. The VCO has a tuning and supply port that are being supplied from the PN400. The PN400 is also connected to the PC over USB, and it has its own external power supply. So let's go ahead and start this measurement in Spike and see what it looks like. Okay, so with the Spike software running, we can start making VCO measurements by selecting the analysis mode dropdown and selecting VCO characterization. That's going to put you into this screen, which shows you a bunch of empty plots, which will be swept once we've configured the PN400. For now, I'm going to add an additional current plot, and I'm going to replace the harmonics plot. So we have 4 plots that we're going to be sweeping. We need to now set up our PN400. The VCC, we're going to be supplying that for this VCO, so I'm going to enable that output. And I know that VCC wants a 5-volt out supply, so we're going to set it to 5 volts. The tuning range on this part is -0.5 to 23 volts. For this test, we're going to only measure 20 points, and we're not going to add any additional dwell time. The VCO outputs about 0 dBm output power, so I'm going to leave a little bit of room for margin, and I'm going to set the reference level to +10. I'm also going to leave the auto frequency range enabled. So the SM435 sweeps very fast, so it's going to have no problem finding the peak of the VCO on each voltage tuning step. I'm going to leave the rest of the settings default, and we're ready to start the measurement. And to do that, all you have to do is click single step, and that's going to initialize the VCO, and then it's going to start sweeping here shortly. So you can see the plots are actually updating in real time as the tuning voltage steps. We can measure it as it's going. We can see that at -0.5 volt tuning supply, the frequency was 8.5, roughly 8.6 gigahertz, and the sweep is actually finished now, and we can actually move our marker to the final output, 23 volts tuning supply, and the frequency is roughly 22 gigahertz. We can actually see the power over tuning voltage here, the current, and the sensitivity. So as simple as that. And all these plots can be exported manually, each one individually, or you can use the file save as image. So all this information can be exported outside of the Spike software for future analysis. So this can also all be automated using SCPI commands. So it's as simple as that. So in this video, we showed you how to use the PN400 and the SM435 to characterize this wideband VCO. The PN400 combined with the licensed Spike software is a powerful VCO characterization tool offered at an unrivaled value. If you have any questions, please email them to us at support@signalhound.com or leave your question in the comment section below.